proceed or we give a few minutes? We give a few minutes? As many as of the opinion say aye. As many as of the contrary opinion say nay. The Kenyan way, nays have it. So we can give them a few minutes? Yes, like 5. I'm not a good storyteller, but I can say something. Now, thank you very much. Allow me to take the liberty as we wait for our colleagues to join us to introduce myself. I can do a little bit of introduction. My name is Anthony Ambugo. Currently, I'm the country manager for water and sanitation for urban populations. For the last 20 years, we have been operating as water and sanitation for the urban poor. But we are told within the population that we serve, we don't have people that are profiled as poor. Okay. You know, I'm a speaker. I was not told to present. I'll just speak. Okay. So I think, and that is true, especially the utilities, when you use the word poor, especially in the informal settlements, people feel offended. So it was in the wisdom of our organization, and we
a very warm welcome. This is the Non-Revenue Water Management Conference 2026, and I'm coming to you live from the Lake Naivasha Resort, where we have this conference now for the second day. So right now, I just want you to have a feel of what we have at the exhibition area. So just come with me. As you can see, we have a number of companies that are showcasing cutting-edge technology, all geared towards reducing the non-revenue water in the country. Remember, according to the latest report by WSPs, Kenya's non-revenue water has climbed to 48%. So here we have one of the company's top pipe piping systems that are showcasing their technology. Apart from top pipe, also to notice that we have other companies here. For instance, as you see right here, we have the smart meters. Remember, technology has been cited as one of the initiatives that can be embraced to reduce the non-revenue water in this country. So we do have the smart meters, a company that is showing the latest technology and how we can embrace smart meters. So other companies as well, we do have, just come with me, we have over 80 exhibitors and hundreds of visitors right here. So, for instance, this is Kisumu Water and Sanitation Company. Remember, this is a WSPA conference, and the fact is that WSPA is an umbrella association of all water companies in the country. Financial institutions, because financing of the water sector is very key, and here we have one of the leading companies when it comes to matters technology. So just allow me to engage them. So thank you so much for your time, sir. Just tell us, we see WonderKid Multimedia Limited. What is WonderKid and what do you have for us?
Thank you. It's a technology company. We've been building systems for the water sector for the last 15 years. We have an enterprise solution that's serving 4 countries so far, 26 water companies. And in a nutshell, if you look at that, we've structured it to have different kinds of modules. It also comes AI integrated. Executives do not need to log into the platform to engage with the platform. They can simply chat the same way we do it with ChatGPT. They can engage the platform and get the results, the answers they are looking for on a simple prompt in English. We've designed all this and we've made it available to the utilities that we are working with. And at the conference, we came with a big screen just to show it live. So users have been experiencing it live, and it's really been a great experience.
So let me understand, because we are looking at reducing the non-revenue water levels in the country. So how is your product coming in handy to address this challenge?
Good. So the first thing that we have done as a technology company is to digitize all the utility operations, from production to distribution when it comes to the network, and also the customers, the billing, the meter reading, the meters, and all that. So we have an entire ecosystem that is generating data for the utility, which eventually builds up to what you call non-revenue water analytics. Okay. So we have a whole module that comes with a live Iowa water balance. A live Iowa water balance means they're able to see in real time their production, their non-revenue water, their commercial losses, their unauthorized consumption losses, their meters, and even get down to the DMA level to be able to see statistics of where they're losing water. We've digitized all that.
All the best, Wonder Kid, and good product that you have right there. Yeah, so that's a Wonder Kid Multimedia Limited, and remember we are talking about a reduction of non-revenue water. So other companies right here, you can see some of the latest technology when it comes to piping and piping systems, and we have companies exhibiting right here, and then from there. Key stakeholders in the water sector, for instance, Davis and Shatcliffe, right here showcasing what they do have. So just come with me. Let me engage a representative from Davis and Shatcliffe just to find out what exactly they are showcasing. So Asante Sana, just for a minute, maybe you can tell us what do you have, especially in line with reduction of non-revenue water in context of this conference.
Okay. Oh, okay. Morning. So my name is Samuel Rukwaro, chemical engineer at Davis and Shatcliffe. Davis and Shatcliffe is an ISO certified company. So we basically deal in improving solutions in water and energy. Yeah? So for particularly this conference, we have come up with a package, especially in terms of solar financing. So we realize the biggest demand in supplying water is the energy. Okay. So if you use electricity, it's then too costly even to the consumers themselves. So if you pass that price, it's not sustainable. So in order to be sustainable, we have come up with financing whereby for these public and community-owned water utilities, and especially the ones here in WSPA, we are able to come to your site, we design with you with the energy requirement that you need. Then from there, we give you a 20%. You do a 20% deposit. Then we do the 80% ourselves. Then we will do also the contract, the service contract. So we're going to service it for whole of that period. It's a 24 months financing. Then the money that you save from the energy consumption or the energy that you pay with your electricity, you can pay off this financing, and at least you can enjoy as well as you pay, okay. So that it can trickle down. As well as we have the abstraction meters, smart meters, okay. Especially to enable and monitor the losses that we encounter through the normal meters.
Okay, thank you so much and good job. That's Davis and Shatcliffe showcasing their latest technology and products as well when it comes to non-revenue water. So now this time we are talking of over 80 exhibitors right here and hundreds of visitors coming through. For instance, just to take you through this other side, this is Velo East Africa, one of the companies that is known to have fuel efficient that is energy efficient pumps. So they are right here showcasing the latest technology, and apart from that we do have a mega tank, and Doshi water is right here. So you can just see the bad fusion technology right here, and this is all about making sure that we don't have leakages and all that.
So maybe to introduce water and sanitation for urban population, we are a WASH specialist organization established and registered in UK and Wales 20 years ago. We operate in 7 program countries, and Kenya is one of the program countries. I lead the Kenya country program. And as we do this, we operate within the urban wash space, and more specificity, those people who are residing within the informal settlements. If you come to Nairobi, we work with all cities operating in 7 counties and 8 project locations. You will find us in Mukuru kwa Ruben, where we have had a number of technologies, including simplified sewers, among other, which include interventions in area of non-revenue water, like prepaid dispensers. We don't work directly, but we work with mandated institutions. So in Nairobi, we work with the county government, national government, and we work with Nairobi City Water and Sewerage Company. So if I look at the topic of discussion that I need to talk about, sustainable energy solutions, maybe to start with is to mention that ordinarily, as I had reiterated, that energy cost is one of the single and largest controllable cost in a utility. Most of the time, within the developing world, it is between 5% and 30%. But at times, depending on the technology, especially pumping systems, it may go beyond 40%. So because this is one of the challenges that has been hindering efficiency of utilities, we were able to undertake an investment-grade energy audit in 2012 in 29 utilities. This was sponsored by SWAP BFZ from the Federal Republic of Germany. This was upgraded to 43 WSPs just to determine the energy footprint and find out the challenges and also efficiencies that can be triggered to arrest these energy costs. Later on, we went and did a case study for a number of utilities, and I want to quote it verbatim. So what was done is data was collected for the utilities over a long period of time. That is specific energy bills for 9 years, just to look at that data for over a period of time. Because this is documented and shared with the regulator, I'll be able to quote. So between 2012 and 2020, this one you can cite even in your academic writing, because it is not 10 years old. I don't know, you're taking 8 years or 10 years? 5 years. Okay, it's almost there. So Nzoia water tariff increased only once, while the electricity tariff for commercial industrial 1 tariff increased at least 5 times per kilowatt hour. Where are the utilities in the room? Let me see the utilities. Good. So, of course, you are aware that the regulator for electricity is EPRA, and EPRA has unfettered powers to change this tariff over time. And I think when we were doing the investment-grade energy audit and identifying areas of interventions, some were low-hanging fruits, including what is called tariff migration. Some utilities which were operating on 15,000 kilowatt per hour per month, which is 180,000 per year, were still operating under small consumer, that is a domestic tariff. which is more expensive than commercial industrial one. So simple interventions included tariff migration, just write to Kenya Power to change you from small consumer to CI1. It happened in Homa Bay. The bill dropped from 200,000 to around 140. No cost involved. That is the beauty of investment-grade energy audit. And this is not a walk-through audit. If you go to a treatment plant, you measure everything that uses electricity. Even if it is a bulb or a lighting system, anything. What we realized when I was in Tililbay, we were carrying out these. We realized that misalignment of pumps alone was costing us 3 million Kenya shillings every year in terms of electricity cost. So if you are an engineer, with your eyes you can see that it is properly aligned. But if you check it under the instrument, you realize there is misalignment. Some utilities have pumps which were installed 30 years ago. So when they start drawing power, I'm not an engineer, but they go delta. So they draw too much power that is not pumping even water. So that is another cost. I don't want to walk you into the technical issues, but I'm giving you some of the benefits that this investment-grade energy audit. In Thika, I'm not sure, but I remember some of these lights that were put at the treatment light. They were drawing a lot of power. So the recommendation was to use energy-efficient bulbs. And you see that is cost of lighting. So some power pumps also required replacement to get energy-efficient pumps. Those ones which were going to delta, you put soft starters just to invoke in energy efficiency measures. So I would want to conclude and relate with what we are doing. So overall, like for Nzowasco, for the last 9 years, that was between 2012 and 2020, Nzoia WSP electricity costs had risen from 16.5 million to 74 million. So a 348% increase, or 38.6 annual increase. That is huge. So for Nakuru, water tariff, of course, they are heavy consumers of electricity because of boreholes. The tariff increased only twice, and in November 2020, they received a tariff, of course, an indexation tariff. So overall, we are saying that whereas the tariff of the utility may have changed once in 9 years, then that of EPRA was increased how many times? 5 times. And this is the recommendation we have given to the regulator, which I think the association can pursue through its advocacy mechanisms. That was the case which was happening for National Water and Sewerage Corporation in Uganda. Because there are factors in the environment that you cannot control. One of it is inflation. And when there is inflation and change of tariff, like the cost of chemical. So if the cost of chemical increases and your tariff was for 3 years and you didn't factor that, how do you save that? Your tariff will be reviewed after 3 years. And most of the time, you review it even after 5 years. How many have reviewed their tariff maybe 2 times in the last 10 years? Once? Yeah, once you will get. So it's a challenge because it has a public consultation process. It has the political arm. Next year is elections. Can you go to a governor now with a tariff that you want to change the tariff? Is it possible? So the timing. So if you want a tariff, you wait when they are starting. You will be lucky if you are doing well for them to approve for you now. So some of these challenges, before I conclude with the energy audit, is they require advocacy, and there are those ones that the utility can take advantage in terms of low-hanging fruits, like acquiring energy-efficient pumps, putting soft starters, maybe tariff migration. And also the study showed us that all utilities in the Republic are able to take advantage and use solar. So I believe my colleagues, the panelists, will be talking about solar energy, which can now be gotten in the grid just to reduce. They'll tell us, but I know even if you put solar energy, mostly is to reduce the energy costs. You'll tell us by 30% or what percentage, which is very important to bring the cost lower. The other source of renewable energy is solar and also hydro. When we were doing Tilil Bay on Itare River, we had Lebechet Falls, and it had a fall which would produce 1 megawatt. That was sufficient. But the other challenge, you only need to produce what you need. If you produce more, the feed-in tariff for Kenya Power is low. When you sell it at a loss. They have designed it, and they know that you can't sell it. So there are issues like wheeler. I think that wheeling the electricity, those issues are with, I think, Embu or Meru. So one area that is important when you are going to deal with your tariff, and because in Kenya we have the ETA, extraordinary tariff, which was put in place in 2009 to salvage all the utilities that were going now, and we have the regular tariff adjustment. But WSREB has also the ATA, automatic tariff adjustments. How many are on ATA? How many are on RTA? How many don't know where they are? So you negotiate, utilities, you negotiate tariffs. Now it's good they have given the inflation. But what Uganda did, and there is a case study that we can share and you explore, Chairman Emeritus, we have shared this with the regulator, is that now when they are designing the tariff, they index inflation so that if you have too much money chasing few goods, if the cost of maybe a kilogram of chlorine was 200, and it went to 500, there is a factor for chemicals, there is a factor for electricity, and there is a factor. So what happens, it adjusts automatically. So if you had a budget of 200 million, and you realize your expenses have gone to 250 million, so where do you get the extra 50 million? So the tariff is inbuilt in such a way, like, have you looked at your electricity tariff? Indexation is simple. You look at the amount of kilowatts you have used, it is there. Then when they come, they add additional costs. So you'll find if it is rural electrification, it is there. If they pumped and they were using maybe diesel, you find fuel cost adjustment, which is not a constant in your bill. You've seen that. So that means those other costs apart from your consumption are protected. So Kenya Power will not meet that. I know it might sound expensive, but this is something that has been done in Uganda, and it has been successful. National Water and Sewerage Corporation is one of the most successful utilities in this part of sub-Saharan Africa. So what I wanted to relate, apart from speaking at that, our work now in WhatsApp, we have just entered into the carbon space, the carbon markets. How many have an idea on how you can generate carbon credits when you're reducing non-revenue water? Utilities, do you have an idea how you can generate carbon credits when you're reducing non-revenue water? Can I share something in 120 seconds? Good. This looks exciting. Now, our non-revenue water stands at 48%. That means out of around 504 million cubic meters we produce, close to half of it is lost. So if you translate it in monetary terms, that is around 14.8 billion Kenya shillings. And I think the clarion call yesterday from the chair WSPs, development partners and donors, to have targeted projects on reduction of non-revenue water. So within the carbon space, what we tried to do, but I'll be able to explain at the end, you need to create a baseline. If your non-revenue water is at 40%, what is the baseline that you are looking at? Is it 30%? So that saving of 10% is what you quantify. So if it is 100 cubic meters that you intend to save, so if you save this water, there will be reduced electricity, there will be reduced costs of electricity in terms of pumping, in terms of treatment, in terms of distribution. So what you are targeting, because there are emissions associated with this water that is lost, because there was energy which was used. Tuko pamoja? Ama nimewapoteza? No, you target the energy component, because there was energy which was used to abstract, to treat, to distribute that water up to the consumer point. Then now, different utilities, of course we are given a standard, you cost your cost of production in terms of how much Kenya shillings of electricity do you use to produce 1 cubic meter of water. So when you get that volume, of course the figure that is given conventionally is 0.6 kilowatts per cubic meter. So you multiply, then you will find now the amount of electricity. So if you save, now you are looking at carbon avoidance. This is what now you convert into carbon dioxide, and they become your carbon credits. But I can give you a caveat. We tried it with Nairobi, Kisumu, Kilifi, and Nakuru. We got the data. But we realized, because you have to give an intervention, because of the low reduction rates, the carbon credits coming from these projects are not sufficient to support a carbon project that can be registered. But if you are sure you are going to reduce non-revenue significantly, especially utilities like Nairobi Water, then you have opportunities. The other way is to amalgamate, and that is what we are doing now within the fecal sludge management space. Amalgamate utilities, ensure the fecal sludge that remains in toilets, it remains in septic tanks and open sewers, is safely managed and aerobically treated, converting it to carbon dioxide, which is 28 times less potent than methane, because when you are looking at greenhouse gases, you are looking at methane. So if you are able to convert it into carbon dioxide, then 1,000 tons of carbon dioxide give you 1 carbon credit. And in the Kenyan market now, we have a carbon registry. 1 carbon credit is sold at between 40 to 70 US dollars. So this becomes another form of alternative financing. So for fecal sludge, we are progressing well, but what I wanted to address in terms of looking at the nexus between non-revenue water and energy is that there is still opportunity to generate finance, climate finance. It can be unlocked. So with those many, many words, allow me to stop. Thank you.
Thank you very much, Anthony. We just lacked the time, but that was a very good lecture, or a good speech. So we have 2 speakers in this session. I'm inviting the second speaker. For those who came a bit late, I'm Simon Mdondo. I'm the moderator of this session. We are doing it together with my colleague, Engineer Njehia. So I want to invite the second speaker, then we'll have a brief question and answer session where we will invite the plenary to make their comments, to raise their questions before we proceed to the panelists. So the second speaker is Engineer Thomas Nyang'au. Engineer Nyang'au is a manager, commercial and financing at a Water Sector Trust Fund. Engineer, you are welcome for your speech. Thank you, Karibu.
Thank you very much. I'm going to facilitate this session on behalf of Ruth Nganga, who is a GM for fund development. And I'll straight away go to the theme, innovations. I'd given the presentation, but I'll be able to facilitate. If it will not be, yeah. So I'll be able to use both the presentation and also the on innovations, technologies, and market opportunities. But to give context, the Water Sector Trust Fund is one of the state corporations under the Ministry of Water and Sanitation and Irrigation. We work with county governments and most of the WSPs, and I see familiar faces here, in extending financing for development of both water resources and water service provision resources, and also sanitation. So in terms of looking at the innovations and technologies and market opportunities, I'll center my discussion on what, as a financier, how we are able to structure programs to mainstream some technologies in our programming to be able to execute our mandate, that is water service provision financing. We have had quite a number of programs which are ongoing and others are upcoming, and we're looking at when you look at the energy usage across the various utilities, that's the key cost. And that has been really the critical challenge when you look at the sustainability and the creditworthiness of utilities when we are trying to drive them towards sustainable financing and financing by capital, by raising their own capital. So when we are talking about the energy efficiency, there are quite a number of areas, but I look at, first of all, the market or the manufacturers availing technologies that are by themselves energy efficient in terms of energy consumption, but also from the engineering perspective in terms of design. The engineers designing both mechanical and electrical, sizing the infrastructure to be able to meet the actual requirement. That's to avoid oversizing that also affects the consumption. And I'll also move into an area where what are these innovations that are in the industry, and also how then do you bring them on board? For utilities that are able to save finance, that is okay. But from yesterday, we are looking at the level of NRW, and then it means that the amount collected is quite limited, and therefore, we need to develop innovative financing and then embed these technologies so that if they bring about the reduction of wastage, the amount that we're able to receive from there, we can be able to now use those funds for just dedicated financing of those self-technology uptake by the various utilities. So at Water Sector Trust Fund level, we have been able to implement the program that we're finalizing, where we really supported the uptake of solar systems. That has been very good. For instance, in Isiolo, we have Nanyuki, and also we did support the retirement of the diesel generators that were really also using the diesel. So trying to support the utilities to use the more clean energy sources, and also bring on board energy efficient technologies. So at the fund level, we look at the opportunity to, designing our systems, to, if we can be able to have a project that is having reduced pumping systems and taking advantage of gravity system, that's when we go for it at first level. But if that's not possible, then we move forward and say, okay, what then do we have to do? We move and integrate the electricity-powered systems and also solar. And at the north, where we have a lot of wind, we also consider the wind systems. So at the water sector transit level, and I'm looking at this session, we were actually requested to speak on the program that we are developing that is upcoming. It's called the Energy for Water program, where it will be specifically bringing on board and supporting interventions that are going to support the use of energy efficient systems and the reduction of waste, including the solar systems having energy efficient pumps, and also we are trying to consider the use of the mini hydros. So we are at the design phase, and that is a very, very key opportunity. But the end, it will be mainly determined by the result of the energy audit, and I think the first speakers really detail on the necessity of the energy audit, and working also with all the stakeholders in the energy space, especially for regulation and also approval of those energy audits. So something that will be able to be moving around in the next 12 months, and we'll be advocating for energy audits And after that, then, from the energy audits, you're able to get what are the recommended action plans. And that will form the basis of that upscaling of the project financing. That's, then when you look at that, now after the energy audits especially, they are programmed to be supported by the MAF, called, it's an acronym MAF, the Mitigation Action Facility. So we'll then be able to structure what are the possible financing mechanisms that will now be able to support particular and individual utilities. So those are the, I just say, those are the normal systems. I just want to now bring what are the particular financing mechanisms that we foresee that now will be able to uptake the various energy technologies and systems. And that's what, first of all, we will consider the use of the PPC. And also, we'll consider the PPC has been mentioned from yesterday, the performance-based contracting, and therefore, part of the key outcomes or measurable parameters will be the reduction of the energy usage according to the recommendations of the energy audits. And also, we'll consider also the results-based financing. Those two will be the key financing streams. After we undertake the energy audits, then we'll be able to structure what is a particular arrangement that will suit each in the rest of WSP. As I tailor to the end, in this, then in that phase also we look at the reduction of the CO2. And that's part of now that we are going to reduce the energy wastage and introduce efficiency, what will be the resultant energy savings, and then take account of that. So those will be measuring the key targets, the reduction of energy, the zeroing in on key metrics of performance at the WSP, zeroing in on key metrics of performance at the WSPs. So I have some figures here. For example, this is the PPC that I've said, where now we'll just be onboarding the private sector. I don't want to preempt what the speakers are saying. I'm just providing the overall perspective and the overarching level. So as I finalize, as a water sector trust fund, I'm saying this is an exciting opportunity. So we look forward to bringing you on board in the design phase of especially the Energy for Water program that's under design and detailed preparation phase. So thank you very much.
Okay, good afternoon. My name is Engineer Njehia. I'll be taking over to introduce the panelists. To go on from, we have heard from the finance perspective and also from the engineering perspective. So I'll take this chance to invite my panelists so that we can go on with the discussion. Then at the end of it, we'll invite questions for the speakers and also the panelists. So our first panelist is Engineer Nahashon Wahome, MD for Naivasha Water. I don't know if he's around. Yeah. Karibu engineer. Then our second panelist is Engineer Jen Morege, MD for Kikuyu Water. Karibu engineer. Then we have from Willow, East Africa, MD, Belete. Karibu. Then from Grand Fonds, we have the county director, Bwana David Githindu, Karibu. And then from Alpha S, we have the business development director, Bwana Toby Chen, on representative for Alpha S, if they are around. So these are our panelists. And to save on time, we'll just start with our first panelist, our MD from Naivasha Water, who will be telling us on energy cost structure and renewable energy non-revenue water management strategies, looking at the percentage of OPEX in energy related, and how the percentage on energy related, how much is the energy related COPEX take. Then still on the same, the strategies they are applying to reduce on non-revenue water. Okay. Welcome, engineer.
Thank you. Good afternoon. Yeah, to give you context, I think it's good to say that Naivasha Water basically relies on groundwater systems, and most of them are placed around the lake. And therefore, we do 100% pumping of all the water that is consumed within Naivasha sub-county. And sometimes we will pump over long distances. I think our longest pumping main is around 20 kilometers, and also very high elevations. There are areas that are about more than 200. We need to pump for more than 200 meters above from the lowest borehole. On average, we use more than 1 kilowatt hour to pump 1 meter cubic of water. If you look at our costs, that represent, electricity costs represent about 40% of our O&M costs, which basically it's very, very high. And this is contributed by the high cost of power, and again also the losses that we make. So we have different ways we are trying to manage these costs, because energy management will require, it's basically a multifaceted, will require a multifaceted approach. And therefore, as Anthony had alluded to, we need to optimize our pumps. We need to also manage our NRW. And more so, we need to also look at alternative sources of power. What happens is that for a 24-hour supply system, if we are able to reduce our NRW, then it means that we're also going to reduce our pumping hours, and therefore the energy requirement will also go down. And that is one of the key things that also we are looking at, reduction of NRW, as much as also we are looking at alternative sources of power. As Naivasha Water, we have explored different sources, and one of the key sources of power that we are now in is a solar power system. And our objective when we were getting into it was to, number one, to reduce the costs of production, and number two, again, was to increase reliability. So most of us who rely on Kenya Power, I know they have also suffered from a lot of interruptions that, again, affect the reliability. So what we did is that we went into the market, and we were able to get somebody who was to provide solar as a service, or a farm that right now they are providing solar as a service, because we didn't have sufficient resources to meet the initial cost of erecting solar systems. And we pay based on the amount of power that we are consuming every month. And they are relatively cheaper as compared to Kenya Power. We have a hybrid system. So when we have prioritized on solar, if you're not able to meet power requirements from solar, basically because of different reasons, it could be at night, or maybe because of weather issues, then now we switch back to grid. We have about 1.732 megawatt system that we are currently using, and we were able to implement that in 2 phases. We commenced that project around 2021, and we were able to finish around 2024. So just want to share with you a few data that will help you understand what we've been able to achieve through that system. Around 2023-2024, our NRW was around 25.5%, and currently it's around 24%. If you look at cost of power as a percentage, or cost of electricity as a percentage of O&M, at that particular time, in 2023, 2024, it was around 41%. And this year, we've managed to reduce this to 36%. We're also looking at it as a percentage of non-labor O&M costs. And in 2023, 2024, costs of electricity alone, without considering other costs of production like chemicals, WRA charges and the rest, cost of electricity as a percentage of non-labor O&M costs, then it was 74%, but we've managed to reduce this now to 65%. That means that around 3/4 of what we use to maintain, to repair, to buy chemicals, and other operational issues, 75% of that would go to electricity. We've managed now to also reduce the amount of money that would lose per meter cubic. Initially, if you look at that 74%, or looking at the NRW, we had 25.5%. If you translate this to amount of Kenya shillings per meter cubic, initially it was around 7 shillings, but we managed to reduce that to 6 shillings. And essentially also the cost of production has come down from 37.96 to around 30.74 shillings per meter cubic. I think that's all for now. Thank you.
Thank you, Engineer, for the good insight on the way you are approaching your reduction on non-revenue water. Then I would like to invite Engineer Jane to give us a talk on energy efficiency that are driving a reduction on the same non-revenue water. And he will tell us how does energy efficiency improve non-revenue water performance, and also lessons from his utility on how they handle energy management. Welcome, Engineer Jane.
Thank you. Good afternoon, all. Yes. My name is Jane, Managing Director, Kikuyu Water Company. As my colleague here has also said, we are also operating under fully pumping. The situation was as described by him, with a lot of interruptions from power and the fairly high and sustainable bills. With energy efficiency management, we considered 3 key issues. 1, management of the cost by solarization with the hybrids. Our approach was, we undergo the initial cost and save 100% of the benefits of the solar energy without having somebody else to pay, such that we do not have to pay Kenya Power and also bother with paying the service provider. We've managed to do 674 kilowatts, half of what they have. And with this, we have managed to do a savings of 30% to 40%, depending on where our installations are and the solar radiant strength. Kikuyu is generally a cold area, but we considered also in the efficiency the designs of our solar systems, location, and also the quality, the highest quality we could get in the market. Initially, our 62% of our revenue was actually going to paying only Kenya Power. Currently, we are stabilizing at around that 8%. So with that, automatically our company was able to break even. What else did our energy management do? We also concentrated on selection of the right pumps with the right efficiencies, and together contributed to the energy costs. 3, we also were keen to have, when the solar is hybrided with the grid energy, the less continuous supply of water. Those who are very keen in NRW management, when you are on an activity, or maybe check on the pressures so that you can control burst and the rest, and all of a sudden the power disrupts, the whole day becomes useless. But now with solar and the management of energy, we are able to have a continuous supply of water. Hence, we can have our uninterrupted NRW activities, which have been successful. With the steady supply of water, again, where we take our services is to our consumers. Those who are service providers, with the constant supply interruptions, the customers also lose confidence. Immediately you lose confidence, they are also not willingly paying for the bills. Coupled with this, our customers have confidence, and you can feel the reputation of the company also improved. We also allowed to use the proactive approaches, knowing which energy source to use, which pump to use, and which components to couple with our hybrids to ensure that we also do not have downtimes. Downtimes also influence the quality of service we give. So we are giving it energy management as both commercial and also a social aspect coupled with the economy in it. By that period, that is 2020, when we started these initiatives to do enough energy management, our NRW was quite high. We were at 54%. We are now at that 3%. How? Every other time, when you are thinking of how to do the power bills, your concentration leaves from thinking of improving the services to how you pay the bills. Normal operations. Savings we made, we dedicated back to also NRW management. Mostly we did, we were working on RIC management and deductions. We are also rehabilitating the very old pipes, and we are also doing customer meter replacements, did also the DMS, and now working on preventive measures. Those are the measures that we have been able now to concentrate on, because we have been able to get quite enough of the savings and enough of our work to just concentrate on what we should be, rather than leaving external threats. Did our analysis and found our greatest threat was the Kenya Power. Our staff used to think that we work for Kenya Power than for the company. Lessons we learned: integrate energy with the NRW reduction plans. These two create synergies. When you do we do our energy integrated with an NRW, we are able to get quite a good milestones. The others too can run. Learning number 2, lesson for others. Solar energy is free just like tumesikia maji ya fisi. Only that, there is the capital, investment, and we are here with a number of investors who are also willing to support us. Let's take the investment on the solar very seriously so that it can give us the concentration to do our real main business. Lesson number 3, we need to run. Let's conduct regular energy audits. We also identify the efficiencies, we monitor performance, and guide our investments. And the most important lessons we should learn today. Thanking the WSPA, we being one, bringing us together with the investors and those who are having the technologies with us. We take a lot of keen interest to know what others, the engineers, are innovating for us to be able to manage the NRW. I remember one case study have always bothered me. We came from PVC pipes, then we had GI pipes, now we are HDPE, and we are happy saying with the pipes. How are we addressing how we couple the three? We reduce the rents because they are longer, but we leave the rigs at the point of connection. I think when I was going round, I've been able to see those technologies coming with very good mechanical joints, which will be coupling between the different types of pipes that are involving. And it has been lagging behind. The mechanical joints have been lagging behind, but through the exhibitions here, I can see. So let's all take the advantage, see what is there, put into practice, and change the story. Pumping stations are sustainable. That is my parting shot. Thank you.
Thank you, Engineer, for the good insight from a utility point of view, based on the energy efficiency and how pump selections can be of great improvement of our utilities. Based on the same, I would now like to invite Willow, Mr. Belete, to give us the technology that are there and how they are integrating them to handle these energy efficient pumping systems, and also smart pump technology in the market and how the manufacturers are doing this digital integration so that we can be able to monitor our systems as we reduce on the non-revenue water. Welcome, Bwana Belete, to give us your view.
Asante sana, habari jioni. My name is Belete Matebe. I am a managing director for a company called Vilo. It's a German company which has been in this business for the last 154 years. One of the leading water pumps and pumping system manufacturers, especially for high efficiency and smart pumps. And I'm happy to sit next to engineer. She's one of MD, which she has our solution also. So this is very interesting conference. We are talking about non-revenue water, but all these non-revenue waters, they have non-productive energy. So our focus is on the pumping stations. And currently, Kenyan utilities totally, they pay around $80 million for electricity bill. So they have lots of pumping stations, which gives more money for KPLC than the water companies. So we are targeting those opportunities. The first one is, if you see most of the pumps, they have been there for 30 years. I was in Limuru Water, they told us they are happy with our pumps, which they installed in 1980 something. Yeah, that is good, it shows reliability, but that's not the model. That pump of ours is giving more money for the KPLCs and the Limuru Water. So One of the opportunities there is changing the pumps. Now the technology is improved with improved hydraulics. Motor technology is improved. We supply this time IE5. And there is wrong conception. Even today, I hear it again and again. Soft start cannot save energy. It has to be variable speed, where you, a little bit technical, where you can run the pump wherever you want. You manage pressure and other things. Then pump sizing. Most of the companies in Africa, they are throttled. Throttled means we use valves in order to correct, like the duty parameters. It's against energy. So this is where we see as opportunity to correct. The second one is there is no data. So all the pumps are not smart. So they are abandoned. Nobody has, especially imagine if you have a report for the pump efficiency, how many kilowatts it takes, reservoir level, pressure, flow, and other things, this is something missing. So another opportunity is digitalizing such kind of parameters. The third one is the biggest obstacle for water companies is not technology, it's financing. So yes, we saw our pumps, we want to change it, but Limuru Water doesn't have money or something to change all these pumps. So this is where, and most of the purchasing habits that we have is based on CapEx, and CapEx doesn't give you 10% of the life running cost. Usually it should be performance contract based. When you buy a pump, the biggest cost is the running cost, not the upfront cost. So this is an opportunity where we do such kind of job outside Kenya, where we have a project in Jordan where we replace your pumps in your pumping station. We don't need your money at all. And then we replace it only from just the energy saving. And we have seen it in the Nakuru case, their borehole pumps. Just 10 months electricity bill saving is buying a new pump. Imagine your return on investment is 10 months. Of course, you cannot do all these things alone. And the fourth opportunity is partnership ecosystem, where we want to engage the government when we do this project, the sector organization like WSPA, WSREP, development partners. We have seen a lot of appetite is there, KWASH, World Bank, local banks. They are familiar to give you loan for real estate developers. Imagine real estate developers, they develop and they struggle to sell the house to pay back for their loan. But if I change one pumping station at Kukuyu Water, the next day they start generating revenue. Most of the pumping stations, they work 24 hours. So it is easy, or what we are doing is sensitize even the local companies to educate them. There is big money, there is fast money by doing energy saving, especially sustaining the revenue of the water companies. And these are the opportunities that we are seeing. Thank you.
Belete, for the good insight. For our utilities, take advantage of that. You can do partial payment of your pump, and then you have mentioned within 10 months the pump is able to repay itself based on the amount of revenue you are generating, and also on the reduction of the running cost. On the same, we have another giant on pumps, Grand Force. Our county director, Karibu Bwana David, to give us your insight on operational saving and adaptation barriers of these technologies, on how we can embed them in our utilities to save on cost. Karibu Bwana David.
Thank you. My name is David Githendu. I'm the regional director for Grundfos in East, Central, and West Africa. And Just I might recap some of the points which some of the speakers have mentioned, because these topics are very much interlinked. But when you are looking at non-revenue water, and it clearly comes out from a lot of the discussions, there is of necessity that linkage between non-revenue water and energy costs. And that is how you will find water utilities also. It's very easy to get into that investment trap, because if you are having a high percentage of non-revenue water, which means you are not getting revenue from the water that you're actually distributing, then you say you don't have money to replace old equipment, and you keep running the old equipment at very high, very low efficiencies, and you continue investing, putting in a lot of money to Kenya Power, which you don't have because you are not collecting money anyway, because a lot of your water is non-revenue water. So this is a very serious problem for a lot of water utilities, and it's not just Kenya, it's everywhere. Here we are talking about 48% non-revenue water, which is of course very high, but even if you go outside Kenya into the rest of the African countries, we see also between 40 and 60% non-revenue water. Even if you go to Europe, they might be lower than us, maybe there might be 20%, but still 20 to 30% is still a lot of revenue lost. So what are the technologies that can help us to reduce non-revenue water and also reduce energy costs? One of the things that is not considered a lot of the times is simply pressure management. And what are we talking about when we are talking about pressure management? If you have a pumping system, then you have, of course, your distribution areas where you are distributing to, and you need to have a system that covers the total head and, of course, the flow that you need to be distributing. But a lot of the times, many pumping systems are not accurately designed. I was happy to hear Engineer Jane talk about they were focusing on making sure they are running the pumps at the correct duties. But in a lot of historical cases, already the pumps have been oversized. In fact, in my life as an engineer in the water business, I have never seen a pump that is too small, always too big. Because generally as engineers, we are trained to work with the worst case scenario. So you will find when an engineer is working out the size of the pump, most of the time they take, the peak demand, and maybe the peak demand is only 2 hours out of 24 hours, and they use that to design. Now, if you are running your pump at that peak demand for 24 hours, the pump running at the highest speed, then you are wasting a lot of power, number one. Number two, if you have got old infrastructure, you have got pipes that were installed 30 years ago or 20 years ago, a lot of them already, they are weak, they have got joints that are busting, or the pipes themselves are busting. So you can imagine, if you are running the pump at the highest speed, creating a lot of pressure into a system of pipes that are already old, number one, you are losing a lot of water through leakages, but number two, you are continuing to break down those pipes because you are already running the system at a higher pressure, and the system is old. So the solution in this case is something that we call demand-driven distribution. And what is demand-driven distribution? Is a system whereby you locate sensors in your distribution network at the various critical places where you need to distribute water. And those sensors are smart, which means they log the data of the distribution system. So over time, over a period of 24 hours or a week, or 2 months, you log the information about what is the pressure at night, what is the pressure during the day, what is the flow rate, and all that data is sent back to your controller, which is an intelligent controller, and therefore the controller comes up with a model of your distribution system, and it knows at what is the pressure requirement at the various critical points in your distribution network. And because it is running variable speed drive pumps, then it is able to control each pump to run at the most optimum speed to generate the pressure and the flow that is required at the different areas that have been mapped. So using this kind of a system, you will find that you will probably be able to save even 40% of the energy that you have been running, even when you have sized the pumps correctly, because the system will run the pumps at the speeds that are accurate to generate the pressure that is required. Number two, you will save non-revenue water because you will not have leakages. When you pump at the correct pressure, you are able to reduce the leakages that occur within your system. So that's one of the technologies that we have seen and we have used in places, and is something that I would encourage water utilities to try, especially where you have got old infrastructure. And now we have opportunities to do this kind of thing because we are also discussing financing models. This is also one of the things that we can look at. How can we partner with you and provide the financing that you need, and then you will pay back the investment using the savings that you're making. It's very closely linked also to doing pump audits, energy audits, because the energy audits, by installing new equipment, then you save on the running costs and you're able to recoup your investment using the savings. The second thing is, and there is one of my colleagues here who talked about lack of information, but it is where you have, you can say, systems that are not data-driven. So you do not have the data of the system that you're running. You do not, for example, know how much power that you are using. You do not know how much water, kilowatt hour you are using to generate the water that you have. And you could get a lot of benefit by installing remote monitoring. We have tried that with some of the water utilities, where you install what we call a Grundfos Connect system. And that is just a system that helps you to monitor all the key components or all the key inputs and outputs of your water supply system. So, and it is a subscription-based system, very easy to install, and you are able to see this pump has been running for so many hours, and you're also able to monitor when does it need service. You monitor the key issues such as insulation resistance, how much current is the motor drawing for it to generate the amount of water that it's generating. And by monitoring those, you are able to tell when does the pump need service and avoid catastrophic breakdowns. And also, you reduce your operational costs because you don't have to have people running around with pickups going to different pump stations to just go and check if the pump is running. So that is one of the other technologies which is available and can really help you to reduce your energy efficiency and non-revenue water. The other one which I also see now is beginning to pick up and is something that water utilities can do is use smart meters as opposed to the traditional manual meters. Because when you use smart meters, again, you're able to collect a lot of data regarding your consumption, how much water you are losing, and also information related to the behavior of your customers. You are able to monitor that using the smart meters. And when you integrate all that data and information, then you come up with a system that is holistic, not just focusing on the pump or focusing on the pipes, but you need to look at your whole system as holistic, and that way you are able to reduce both the energy cost and the non-revenue water. Thank you very much.
Thank you, engineer, for the good insight. We have seen that the technology is already here. We can be able to digitalize even our old system using those line sensors, then do a simulation, optimize every drop of water, and also this will optimize the kilowatt we are using to pump our water. For the sake of time, I would like to invite our first speakers so that we can handle all the questions together. Karibu Bwana Anthony and Engineer Karibu. So we invite our guests and our friends for just 2 questions directed to the panelists and also the first speakers. There is a hand behind there.
Good afternoon. My name is Jane Sain from Tanathi, and I have 3 questions for, I think they're even 4. Okay, I'll start with the Naivasha. You talked of a power grid that is hired. So I would want to know how you came to hire that system, where it is installed, whether it is installed within your premises or it is piped to your place. We need that history because we are just about to start a bulk water, and the WSP that is giving us is Kitui Water, that is Masinga system, that the bill itself for 1 month is 10 to 12 million per month. Now, when we come to Kikuyu Water, Engineer Jane, you talked about 62% of the revenue collection was going to Kenya Power. Now, I would want to know, how did you get your seed capital to start solarization? Because you must have started from somewhere. Then about changing of pumps, the gentleman next to Engineer Jane, your name is difficult, I can't even remember. You talked about changing of pumps. The pumps we have there, I don't know about their efficiency, but they know how to take a lot of electricity. So there is power correction equipment, but I'm not sure whether it is working or it is just by the way. So I think there is a study you should come and do for us because of the change of the pump. Because if, for example, when we start operating and we have the seed capital maybe from the ministry to operate that bulk and get that money, and we start saving from the first month, we'll be able to pay back the pumping system because of the electricity power that is maybe half. Then about the ground force technology, I found it very interesting about this energy, this technology that looks at energy costs that are low and on pressure management. We have a particular line that if you open just quarter throttle, you can never go beyond there. Because you go there, you'll find pipes flying because of the pressure. So I would also want to see you behind the tent, that I may also get your contact so that you can also come and study that pressure pipeline. Some of the things that we guess is that maybe the pipeline that was installed did not have the correct pressure, So that is what we guess, but maybe not. It is about the pressure management. Yes, thank you.
Thank you. Thank you for the good, most of them, they are comments, and we can allow a follow-up after the panelists. But I will maybe allow two to answer the hot questions on the capital. Engineer Jane, on how you sourced your capital, and also maybe something from Engineer David on the smart system. Engineer Jane, maybe you can handle the capital sourcing.
It was a long journey. Beauty with our installations are separate boreholes, so it's not one of big system. We did, from the company little money we had, one pilot project at a cost of 2.3 million, which was 15 kilowatts. With that as a pilot, we kept data for 6 months in comparisons. And then we were able to prove this is a working technology. With that, we went everywhere, approached the governor, approached the Water Services Board. We also had an ongoing project on sewer. And now that everybody could see this can make a saving, every other fund was directed towards that. Savings for the project that was going was about enough to do 272, first mega, 272 kilowatts. That was the national government. And with that, the county followed and found, yes, it's working. We got, again, enough support from the county government. And going forward, we are able to change the thinking of our county Kiambu. And going forward, no borehole can be drilled without solarization. So we are no more developing sources without solar. I call it breaded financing from everyone who was willing to, ourselves, our development partners, and our county who owns us. Thank you.
Thank you, Engineer. Maybe, Bona David, you can mention something on your availability to do the field survey on our utilities and how you can be of great help. Together with the other company, Willow, you're also invited to do the surveys and also provide the technical advice to our utilities. Bona David,
Sure.
just shortly.
Thank you very much. I will definitely see engineer later on, and it's something we can discuss. I would like also to add that we are actually already engaged with quite a number of the water utilities here, conducting energy audits, pump audits, and also doing design reviews. And we are tying that up together with this whole aspect of financing, because that's where the pain points are. So yes, it is something, it's a discussion that we can be able to take up with many of you. And the goal is basically to improve the water supply systems by reducing the energy consumption and reducing the non-revenue water. Some of them could be very quick wins by simply, for example, if you have a pump that is running maybe at a very high speed, like engineer was saying, and bursting the pipes, it could be either that the pump was oversized and all you need to do is have a variable speed drive installed on the controller, which will match the duty to the consumption. And therefore, you will gain by, one, reducing the leakages, reducing the frequency of pipe bursts, but also reducing the energy consumption because you're not running the pump at the top speed all the time. So that is a very quick win. By just having a variable speed drive installed on the pump, it could solve that problem. And the other one, you know, which is now, you can say at a more advanced level, is where you do a pressure management system and you map out your whole distribution network to see what is the pressure that should be at each of the critical points, and then you can have a system that is more advanced, which is more intelligent, which will save you much more in terms of energy and non-revenue water.
Yeah.
Thank you, Engineer. We would like to end our session
can
here
I
because
add, Engineer?
Sorry.
Okay.
So what I'll do, I'll be taking the questions. We are around till late today. So let me take the questions, written questions, and then I will have them answer them at any time. The good thing, we also have dinner, so we will have an interactive session so that we can allow the second session to start up. Thank you, my panelists, for the good discussion. Willow, you would like to say something?
Because I know her project, this Masinga Dam, and this is one of a good example that Engineer David said. Most of them, all of them, pumping station in Africa, they are oversized. And I know about your projects. The first pump, you abandoned it because they were 700 meter cube per hour. And then you buy 300 meter cube per hour then. I know about it. But just simply, rather than to abandon the pump, if you buy VFD, you can maintain the pumping station. Another one is solarization. Most of the time when you do solarization, please be careful because solar has only 6 hours of energy. And most of your utility, it runs 24 hours. So you need to invest parallelly on your storage on the other side to pump whatever demand you pump over these 6 hours. At the same time, your pumps has to be upgraded. So in order to get it in 6 hours. So I've seen when I'm an energy consultant, I give a training, and most of people, they told us the water company invest already on solar, but their energy bill is not going down. And because you have small storage and you feel it maybe over the night when your solar is not there. During daytime, you might have less demand for it. Yeah? This is something I want to emphasize. I am working with your technical manager on your projects in terms of upgrading from 300 to other places. Thank you very much. Thank you.
Please have your questions written, I'll take them. So I will invite the chairman for this session, Dr. Mdoda, to come. We take a group photo, and we end there.
I will invite the official photographer to come, and the panelists and the speaker, please come forward so that we can take a group photo. Thank you, the speakers and the panelists, for your wonderful discussion. There was limited time, but the speakers and the panelists are available. Your written questions will be handled, and they will be able to respond appropriately. I think I want to invite the group that is leading the second, the preceding or the subsequent session. Engineer Simon, or Engineer Gakubia, you are invited to take over and proceed with the next session.
If you translate the 48% to monetary value, you come to around 14.8 billion losses. While counties are grappling and water service providers are grappling with inadequate resources, we are losing 48% of our water that has been abstracted. That is sad.
The main issue is that most of the infrastructure, water infrastructure, were done many years ago, and they are therefore dilapidated. The other main issue, of course, is technology. Adoption of technology has been a bit slow, and here I'm talking about digitization. I'm talking about smart meters. It's been slow because of the cost.
It's good to move with times because of the rapid expansion, and then with the lack of use of technology to map the reticulation maps of water in Nairobi and the rest of the country. I think it's the high time, first of all, we correct that. So technology reduces the detection time and turnaround time to be able to repair.
One of the strategies is data management. We trust our data, or rather we value, because we collect data, we analyze, so we make informed decision making. The other thing is
information of the chair and the facilitator. And I'm doing that because I am a practitioner myself. I don't know why I was given an abstract session to chair, because I like where we are doing things and making things possible. So why I wanted to make a comment, because I wanted to take advantage of the panel that was here. I don't know whether you noticed that this panel was, for me, yesterday I watched online, and today I've been here in the morning. It was, in fact, the most balanced panel as far as the subject matter is concerned. We had two pump dealers, and we had two utilities. And we are talking about non-revenue water. So I'll give just a few comments. One is, we have all agreed that non-revenue water has a technical and governance component. Now, there are a lot of things we are talking about here are technical. But let me tell you, our governance is only as good as our value system. Whatever issues we are discussing here are underpinned by our values and aspirations. So when you're discussing about non-revenue water, think about our values. And I'll make a suggestion towards the end. The other thing is about now dealing with it technically. We are talking about energy efficiency. We are talking about operational efficiency and many other things. I've always wondered myself, because government, we are not very good at research. And these guys in the private sector are doing research all the time to improve their business processes and the products they offer. What is so difficult in partnering? My answer is, it is not difficult. It is actually us to drive that. Why? Because when I was a young engineer, I noticed a small community that had signed a contract with a pump dealer to be looking at their pump. They never wanted the headache of looking at their pump. They signed a contract. And that thing came out to me in terms of how government can do it also. When Mombasa collapsed, the pumping system in Balicho collapsed, and I was asking myself, now, here we are with a crisis, what is so difficult in getting the people dealing with the pumps to actually help us in this? Because for me, that is why we are partnering. That is why we have partners here supporting us. We need to kind of have win-win relationships with them. I thought that should not go without being emphasized. The other point about non-revenue water is the people who are discussing this issue in this conference are the same people with the solutions. Why? And I want us to, as we live here, we go and look at our basics. And what are our basics? It's about non-revenue. That is why 20 or 30 years ago, we removed the term that was being used before, unaccounted for water, and brought now non-revenue. So ask yourself, as an MD, are you paying your water bill? Because as a regulator for a long time, I have had confessions in my office with staff that come and just say, engineer, unatuambia kila kitu sijui hii, lakini hawa wakubwa wetu wanatuongoza hapa hawalipi maji. Sasa mimi nitafuata aje maji ilipo na wao wenyewe hawalipi? So just let's go and ask ourselves whether they are paying a bill, because that, of course, you send a message that we are serious. I've also seen that either senior government officials or retired senior public officers are the ones with the illegal connections. And this is a fact. It's only that these people cannot say it publicly. But I can say it myself because I've had confessions like that. So let's ask ourselves, if really you are running a multi-million business, and the only thing you want to kind of get, which you can't pay for, is water, surely, I don't think you are serious. So what is our value system? And that's really what I wanted to comment on. Thank you very much. Now, we go to the next session. We go to the next session where we are talking about, you know, this guy is a friend of mine. He's called Simon Thu. But the session is about innovations, technologies, and market opportunities. It's an abstract session. I don't know whether we are supposed to get anything practical from it, but we'll see, because that is part of supporting research and all that. Now, the speaker is Mr. Engineer Simon Thu, who has about 10 minutes or so, and he will tell us about his topic, because there is one acronym there I don't understand, anticipatory UX actions to prevent non-revenue water. I hope you'll be able to explain to the audience. And then after that, then we invite the panel discussions from a very distinguished panel from areas which we are all struggling with, and I hope you'll be able to get quite a bit of information or whatever, cutting edge or whatever you call it, research. That's about it. So I want to welcome Simon to kick us off in this session. I was told there will be no tea break because the program talks about tea break. Simon.
Thank you. Do we have the presentation on? Okay, just to start us off, as we had yesterday and today and in so many sessions about bankability, about asset management, generally about the bottom line. But when we look at the impact reports, only about 10 utilities are really in that category of financeability. So what happens to the rest, the 90, and those are the urban ones, leave alone the rural ones? How do we address improvement in that part? I know the non-revenue water management is perceived as a fast track to that, but it's also very complicated. As you heard also yesterday from Engineer Lima, quite a number of the utilities have been increasing the amount of water available, because the main infrastructure has been financed by national government through the waterworks agencies. But the last mile connectivity is still way behind. Excuse me, do we have the presentation? Okay. So this presentation introduces a fundamentally different approach to non-revenue water management. The proposal is not another technology-driven leakage reduction program. It is a transformation from retrospective reporting towards predictive utility management using customer-generated intelligence. That is the UX. Listen to the customer, see what they are saying. It is used in all other sectors except water. In water, we are mostly post-mortem. We look at what has gone wrong, we do the dissection, and we repeat again and again. How do we transform that? Some of you, I know many of you are young, might remember how Equity Bank started. There's somebody called Mwangi, and there was Munga, who looked at the situation when the Standard Bank and what was Barclays Bank then ejected tens of thousands of customers because they were perceived to be unbankable. They could not reach the lowest minimum, the 20,000. They threw them out. What happened? This was an asset that Mwangi saw and decided how can he capitalize on this. We look at the health sector. We are no longer looking at medical treatment. We are looking at prevention. So it is the same approach that we are proposing for this approach to non-revenue management. Public health approach, not medical treatment. So it is calling on transition for utilities from reactive to predictive institutions acting as an early warning and rapid response mechanism by listening to the customers. And that's why I was so happy yesterday to see the consumers, although they had a bit of a hard time. Let's see how we can incorporate them in these processes, especially at the utility level, not only in big meetings. Sorry, technology, Bado? Can I just have HDMI? Oh, okay, great. Should I point to you or to the screen here? Do I point here? Okay. As we had yesterday, non-revenue water is really appalling in Kenya. 27 at about between 27 and 90%, causing escalating operating expenditures. Most utilities remain trapped in a cycle of expanding production while losing significant volumes through leaks, illegal obstructions, and operational inefficiencies. And so increasing production alone cannot solve our leakage problems. In fact, when I was doing a diagnostic analysis of most of the utilities in Western Kenya, and Nyanza and Western Kenya, we found that most of them were facing this very challenge. Because of the investment from government, they had much more water coming in to a spider network which was constructed 50, 60 years ago, and thus exploding those pipes. There was no last mile connectivity, a lot more water in smaller systems, blew non-revenue water from about 30% to close to 70%, which was obvious in retrospect. So what we are saying is that non-revenue water is not merely a technical issue. It affects public finance, health, and climate resilience, and non-revenue water has already consumed financial resources. Utilities have paid for the production but never recover the investment. Every lost cubic meter weakens the operational sustainability. Okay. And then most non-revenue water systems are designed to measure losses after occurrence. They rarely identify emerging risks before financial and operational damage has occurred. And the greatest information gap in utility management is the absence of structured, continuous consumer intelligence despite customers observing system performance daily. We monitor pipes and meters, but ignore the human sensors. So instead of smart meters and smart technology, we have smart people that we are not utilizing. We have thousands of points at every utility that we are not utilizing that information. So what we need is a paradigm shift towards anticipatory action. And here we bring lessons from the disaster risk management. As you know, we are expecting El Nino. Nobody is, or we can say, in that sector, they're not sitting and waiting and then looking for, okay, now how shall we move people, how shall we move trucks and so on. They have understood which areas are going to be inundated, which areas are going to face transport breakdowns because bridges are going to, and they have stocked food, they have stocked people, they have looked at where logistics are required and put in place, critical places, how this can be done. So in terms of drought, floods, and food security, the systems have shifted to early warning frameworks. And prevention is consistently cheaper than crisis response. So we see how we can apply this to utilities. Detect weak signals early enough to trigger rapid investigations, prevent losses before escalation, reduce emergency intervention, and improve efficiency. So this is what we are saying we need to borrow from other sectors. And that brings me to WISE, Water Intelligence Systems, to transform customer experiences into actionable operational intelligence. And the concept builds upon proven approaches already used in disaster risk management. HWISE, which means household water information, water insecurity systems, and IWISE, which is individual, were originally designed to measure water insecurity. Their findings demonstrate enormous potential for detecting operational weaknesses long before traditional utility systems identify them. Because we do O&M, maybe every quarter, maybe every half year, sometimes annually. We never pick that information on time. And so our responses are after the leak has become a burst, after the pump has broken down. We don't pick the weak signals early enough. And what we are saying is that every household becomes a monitoring station for the utility. Utilities already possess these thousands of distributed human sensors, and these sensors are customers experiencing service conditions daily. The challenge is how to convert the observations into operational intelligence. Most utilities treat customer feedback as a problem. When a complaint is it's a customer service issue. But the water intelligence approach transforms customer feedback into a core operational management function. So we look at what are the examples in terms of early detection of infrastructure and leaks. Many leaks manifest through service disruptions before engineering inspections identify the physical failure. And the customer experiences frequently provide the earliest warning signals. The infrastructure deterioration often becomes visible through behavioral changes before it appears in the asset management reports. And the customers acting differently should be your first clue to impending physical failure. And this mystery of illegal connections that Kobia was mentioning here before. Communities, your customers, they often know where unauthorized connections exist. But the utilities themselves rarely have the systematic mechanism to capture and analyze this information. Secondly, customers frequently observe water quality deterioration before utilities have completed the laboratory analysis, and that is if they get the results in time. Rapid reporting systems can significantly reduce these public health risks. Taste, odor, and color changes, this should trigger alerts. Increased household treatment and illness reports arrive faster than lab results, is what we are saying. And in terms of, yes, this sounds all very good, but has it been tried anywhere? We have tried it in northern Kenya, and not only northern Kenya. I've included Kajiado in northern Kenya, and the people from Kajiado will excuse me. It helps to capture actual service outcomes and reliability, not just asset functionality, which is what we look for. A borehole can be technically functional while households remain water insecure, and the service outcomes matter more than the asset inventories. The evidence presented from Marsabit, Turkana, where we undertook this exercise with Strathmore University and UNESCO and the World Food Programme, demonstrated to us and also Kajiado how experiential monitoring reveals operational weaknesses, reliability challenges, and emerging risks that conventional utility reporting systems frequently miss. And then in Marsabit, hidden failures were revealed. Marsabit shows that asset functionality does not equal reliable service. Because what used to happen before, they'd count the number of boreholes, the number of water points, springs protected, and this and that and that. That is what they would put in the report. But when you checked on the ground, most of these were either sub-functional or had even stopped working. User feedback reveals interruptions, the coping costs, and reliability failures that engineering reports would likely detect late, if at all, or understate. And a borehole can be listed as functional while households remain water insecure. The utilities need continuous service performance metrics, not only engineering inspections. And I'm hoping we have a number of people from the county here, because although we are speaking mostly to water service providers, the companies, still this is a very critical issue for the rural areas. And in Turkana, we identified the reliability criteria we had earlier today. It's lead because localized customer intelligence identifies where technical teams should inspect first, reducing wasted field time, and operational costs. Instead of just trying to cover everywhere or just doing sampling that covers everywhere, focus on where the customers are complaining first, because then you can utilize your resources much more efficiently. And it also illustrates the value, the operational value of disaggregated feedback. The water intelligence converts scattered customer experience into actionable operational intelligence. So how do we translate these signals into physical action? So the triggers for the engineers here, it's like pressure decline. If your customers complain of reduced pressure, you know there are leakages. If they complain about interruptions, you know there is infrastructure failure. If they are switching sources, if they've been collecting water from this place, now they are taking from donkeys or moving to different places, you know that there is unreliability. And the result is that you get faster, earlier leak detection, faster burst response, and reduced physical water losses. Physical water losses require speed, and these signals can help utilities identify where these are. And finally, because we are all trying to look at how to improve the bottom, because you are told, is your proposal bankable? Into commercial action. Communities often know where illegal connections and unauthorized obstructions are occurring. So structured reporting channels should be designed to convert the local knowledge into actionable commercial intelligence. And the apparent losses are often hidden within the billing systems. Linking customer reports, meter records, and spatial consumption patterns will help you improve your commercial diagnosis. Quality surveillance and pollution control. This is normally an issue that customers are very, very fast to report on. Users frequently detect water quality deterioration before formal testing occurs, and the rapid reporting protects public health, utility reputation, and consumer trust. They don't have to boil their water anymore if they can trust your water. And this water intelligence system strengthens contamination surveillance, especially where pipes break, where there is flooding, and where informal connections increase exposure pathways. And in terms of architecture and integration into the utility system, so what are the inputs? Household monitoring via SMS, the SMS, USSD, and WhatsApp reporting channels, which feed into GIS-enabled dashboards. And then this is integrated into existing SCADA systems, pressure flow meters, asset databases, and billing platforms. So this combined data produces stronger operational intelligence. So in terms of achieving integrated intelligence, we have engineering data, which is systems condition, and customer data, which is service conditions, and it results in a comprehensive diagnostic. So the modern utilities require this integrated intelligence. Engineering data is not complete. Customer experience alone is insufficient, but when you put the two together, you can produce operational clarity. But the institutional change from annual reporting to continuous surveillance is profound. Non-revenue water units must evolve from documenting losses to preventing them through data, feedback, analytics, and field action. So for example, if we are producing 20 million cubic meters at about 40% non-revenue water, of course, this was supposed to be based on the production for Nairobi. Reducing the non-revenue water by just 10% recovers 2 million cubic meters of water. And if you estimate that the cost of that is more than 100 shillings, so the utility already has 100 million shillings free money. The cheapest new water source is often the water already produced and lost, and non-revenue water reduction frequently outperforms expensive, excessive supply expansion. So you have seen that 10% non-revenue water can recover major water volumes without new dams, without new boreholes, without treatment plants or transmission means. I wish I knew this before Metropolitan drilled those hundreds of boreholes all over Nairobi, because we had a solution at hand that we did not utilize. So what is to be done? What I'm proposing is a 100-day action plan. You know, in Kenya, we are fixated to 100 days. Day 1 to 30, set the platform. Establish task force, select pilot utilities, like what we had today about what Waterworks is doing with Nairobi Water. Identify a district where you can pilot. Government can move immediately. The first 100 days should prove value through pilots with dashboards, investigations, and visible non-revenue water reductions. This is not impossible. We had today, it is being done, even in very complex areas. So the first month will establish the scope, the geography, the governance, the indicators, the data ownership, and the authority. Without this, the pilots will remain forever pilots. I remember DMAs being done by Silreka almost 20 years ago, and up to today, we are still talking of the same thing. And then, yes, in the 31 to 60, activate these SMS and WhatsApp channels. As we heard, even the chairman of Nairobi was elected through, was it through WhatsApp? So it can be deployed to pick information from the customers. And then map customer reports, build GIS dashboard. I think these dashboards exist in most of the utilities now. And then day 61 to 100, act and measure, investigate hotspots, prepare priority leaks, inspect illegal connections, and publish results. You need credibility before you move forward. Then deploy, act, and measure, how to execute. So the phase 2 is to deploy intelligence, convert citizen feedback into operational intelligence, and utilities begin mapping the leakage, the illegal obstruction, and the contamination hotspots. Like yesterday we had, where there is crisscrossing of sewer lines and water lines and so on. It's very easy to pick it up from customers and be able to take early action. And the final phase demonstrates the operational value. The government should demand early evidence, leaks repaired, illegal connections identified, pressure improved, and water recovered. Remember Alima saying he keeps calling Nairobi Water, kuna leak hapa, this is happening, and nothing is done. So now you get an opportunity to really emphasize and put pressure from all sides, especially through the citizen. So we can also see how to scale this for national scaling and for the future. So we create a national water intelligence platform so that utilities can learn from each other and the rural areas can also learn from each other. Once the pilots have proven the value, the water intelligence should become part of the National Utility Performance Management and NRW regulation. I'm just hoping WSREB can absorb this because it would be very, very useful in terms of improving performance without the billions that we have to borrow. The most expensive water is produced, distributed, then lost before generating revenue. So this water intelligence approach helps utilities prevent that loss before it becomes financial damage. So these water intelligence systems is the next frontier for non-revenue water management. Thank you very much. I will stop there. So now you know what UX means.
I think it deserves another round of applause. Thank you very much, Simon, for really highlighting the importance of anticipatory action. And I don't know why, maintenance has been an issue which the water sector has not been able to sell to anybody, and perhaps even to themselves. Because, the problem with the pipeline is that if there is a leak and you pick a piece of rubber and tie it, it continues to deliver, isn't it? You only get really kind of serious action when that leak, you can no longer stop it by tying a rubber. That is why it is important to actually have effective maintenance strategies for your water system. And the other issue is, when you talk about non-revenue water to a politician, he will never support your budget request because it doesn't mean anything to him or her. Ama imebadilika. So when we talk about dealing with non-revenue water, it's about also changing mindsets, leveraging technology, which we will see here in a number of presenters, how they have used technology to actually deal with it. But still a very strong change in their governance system, a very strong change in behavior. Because governance starts by behavior change. Innovation is also about changing a mindset in terms of how you think about issues that you are trying to address. It's not only about technology. So we are going to have a number of presenters. I can see in my list there are 7 presentations. For me to be sure that they are all in the house, I want to request them to come one by one and maybe also sit here so that it's easier in terms of time management. We will be hearing a presentation from Beth Muigai and Diana Chepkoech, Kiawasco. Are they in the room? Yeah, fantastic. Welcome here to the main so that you can just be presenting coming from here, because there will also be questions, I imagine. We will also be having a presentation from Kabi Mwangi, Mwasco. Kabi Mwangi, Mwasco? No? Maybe when he comes, of course, he'll alert us as to his presence. Then we'll also be hearing a presentation from James Gedhige, Geoffrey Madhio Murithi, and Abimelech Murithi Njiro. Mawasco. Ah, fantastic. Then from Nyewasco, step-by-step leak detection to reduce non-revenue water in Rorengo sub-zone. James Mohia, karibu sana hapa. And please note that the Nyeri story, because I've seen a lot of people being excited by the Nyeri story, it was work. Getting into the trenches and actually doing the work more than 30 years ago started, not with even with the reform. Then there is Brian Orwa and Aurelia Otieno from Kiwasco. Ah, good. And then there is IoT-based automation for sustainable, Kennedy Kitinda. Ah, sawa. And then there is Martin Aluga from all the way from Copperbelt, Zambia. Martin Aluga? Okay, fine. Then we can start with the first one, Beth Muigai and Diana. I don't know whether it is both of you to present or one of you, but it's up to you how you have organized yourself. So karibuni sana. You have a presentation?
Good evening. My name is Beth Muigai. I work for Kiambu Water. Thank you, Information, for putting the presentation. It was taking a bit of time. So we are here with my colleague after getting a lot of information throughout the day. So we are here to tell our story as Kiambu Water and what we are doing with GIS. And the intervention that that exercise is doing magic for us, matters and revenue management. So I will say that we have a presentation on spatial analysis. We are two of us. I am Beth, this is Diana. And what is key is to ensure the information that we have on GIS will help us reduce non-revenue to the sector benchmark. Please move to the second slide. This is our bio. So we are saying that we have a coverage of 56%, but then this is what we are doing as Kiambu Water. We also appreciate what the community water projects still within our area are doing, who happen to do 30%, so our coverage is 86%. We are currently serving around 169,000 residents within the county. We have 12,837 connections. Our non-revenue is 32%. We have an operational O&M percentage cost of 103%. We are fully owned by the county government. Kindly move to the other slide. And this is where our story is now. We have done a lot of mapping using QGIS and also using ArcMap. We have mapped our infrastructure, that is water networks, and also our customers. But for a long time, that information had been somewhere in our desktops. It was also somewhere on the maps at the notice board. So we now have retrieved that information, and we are now going deeper using spatial analysis to now help us make more informed decisions. So what we are doing is we are using the spatial analysis so that we can be able to visualize where these leaks are. This is an example of how we have been able to bring in the bits and bits of information, and the coloration is as a result of us now narrowing down to where those leaks are. With this, we are able to now be able to see, you can see the color, the red color now shows that the incidence levels around that area are very many, so that means the leaks are there, and the green, which looks like vegetation, shows that the incident levels around that area are not as many as we would be thinking. So this powerful tool is now helping us to visualize when we present these to the investors, when we present these to our board, we are now able to confidently say that the resources that we are going to put together are going to help us now improve non-revenue from the 32% you saw to the journey that Nyeri has walked, probably to the sector benchmark. So what is this information that we are putting together? We have information on our pipe networks. The pipe networks, we know there is material, there is also age, there is also diameter, there is also population that is being served. So that information, when you cluster it together and then you use the spatial analysis tools, that will now be able to give you the other map that we were having, and this will be able to reduce this to the decision-making process so that we are able to now commit the resources to that. So we are saying that information that we had, we will look at the bus, we will also look at the infrastructure, and we'll also look at the data integration. That will be using the spatial analysis approach, and this will factor on the various areas that we have, and it will give us the map that we had at the beginning, which will be able to zero down on where we are going to put our resources. Next slide. This is almost what I have said. So what is the objectives that we are having? We will map the NRW-related incidences. We'll analyze the pipes and burst patterns that we are having, and we will look at the contributing factors that result to the bursts that are there, and these will be able to make us have the decisions that we are saying, and these will help us in the planning. This already is something that we started recently, and we are able to utilize the spatial analysis tools. As we go on, we'll be able to see that. Kindly allow me to also have my colleague to come on stage so that we can do the presentation together.
So I'm Diana from Kiambu Water, and I'm going to take you through the rest of the presentation. And our data sources, we were able to collect data, that is our network data, including the pipeline data, which has the material, size, age, and all the other attributes, and our service area as well. And then also we have the incident records, that is the bursts, the leaks, the customer complaints, and these records are captured by everyone, by all the employees, and at some point we're able to introduce an incentive of, if you report a leakage or a burst, you're rewarded with 50 shillings airtime, and that is how we are able to motivate the rest of the staff to keep reporting the incidences. There's also the methodology, that is data collection of the incidences, the complaints, and the pipe network. Data cleaning also was very necessary, and we were able to work on the attributes and validation of the data. We were able also to merge all the data sets that you captured from the field, and then now that is the the key point now was spatial analysis, where we were able to run various analyses, and especially the kernel estimation density, so as to identify the hotspot areas along our network. There's also, after hotspot mapping, identifying the hotspot areas, we're able to prioritize and identify the areas which has to be, to identify the areas that were prone to leakages and bursts. And then now there was resource allocation, whereby we were able to go to a DMA, that is, we were able to demarcate that area depending with the number of incidences and bursts, and now started doing the NRW intervention activities like pipe replacements, meter relocations, among others. These are a map of distribution of incidences along our network. This data is not the entire data. It was collected over a period of like 1 year ago. And you can see how the incidences are spread along our network. And then our key findings were, we found out that the old network, that is majorly the PVC, GI pipes, were prone to leakages and bursts. And it was also common along the poorly joined pipe sections and also high pressure zones. Now, that is the map of the incidence distribution. And from the map, you can see the hotspots. That is, the bigger the circle, the higher the number of incidences. And as you can see from our map, the lines in yellow or golden, those are the old networks, that is the GI and the PVC pipes. And you can see that the hotspots are, that is, they're very prone to leakages and bursts. So we are able to carry out NRW intervention activities along those areas. We're also able to know that along the major highways and also in urban areas, there were very many incidents of leakages and bursts and also illegal connections, which led to increased NRW volume ratio. And also, as I have said, the aging infrastructure, that is the GI and the PVC pipes, were prone to leakages and bursts, and we are able to now prioritize those areas. And there was also a spatial correlation between the urbanization and NRW ratio, because we find that most of the incidents are spread along the urban areas, but they are very rare or scattered along the rural areas or the areas which are not heavily populated. So that is a base map. It is a satellite imagery showing the settlements along in Kiambu town. And as you can see, the highly dense or the highly populated areas with a lot of structures are highly prone to leakages, bursts, illegal connections, and therefore we were able to identify those areas, demarcate them, and prioritize NRW intervention activities along those regions. Yeah, that's just the summary of what I've said. And from our case study, we were able to replace, that is the old pipes, that is the GI and the PVC. Along our network, we are really working on clearing the old network, especially the PVC and the GI pipes, and we are replacing it with the HDP. And also the demarcation of DMA networks was also based on these hotspots, NRW hotspots. And from then, we have been able to demarcate 12 DMAs and do all the NRW intervention activities, including pipe replacements, meter relocation, among other intervention activities. Our key takeaways, GIS is an important tool for NRW management and identifying of spatial distribution of NRW hotspot areas. And as I've said, PVC and GI pipes are highly prone to leakages and bursts. And The urban areas and the densely populated settlements also recorded the highest concentration of NRW incidents and reports. Integrating infrastructure, operational, and socioeconomic data improved NRW risk assessment and prioritization. And GIS provides a very powerful tool or a platform for targeted interventions, proactive maintenance, and efficient resource allocation. Thank you.
Thank you very much, the team from Kiambu Water. May I invite the team from Mawasco? These Wascos are so many, so they may need to complete what Mawasco is for themselves. Mawasco. This is James Kivige, Geoffrey Mathio Mureithi, and Abimelech Mureithi Njiru. Oh, they are already here.
Thank you for the opportunity that we have been given. I'm Geoffrey Matthew from Madeira Water and Sanitation Company, Assistant Technical Manager. Engineer Kubia is giving me 5 minutes. I'll try to do the best. I don't know whether... Okay, we are presenting synergy between GIS technology, hydraulic modeling, spatial analytics, and in reducing non-driven water. It's a combination of many technologies doing the same work to achieve the goal. You can go to the next slide. Maybe introduction is, you can go ahead. Okay, introduction. The main objective was to leverage geographical information system or GIS technology and hydraulic modeling to reduce non-driven water. I think it's the same story that Kiambu has. NRW remains one of the greatest challenges facing water service providers. In the other day, we earned an impact report. We are at 48, losing around 14.8 billion shillings. In response to increasing pressure to improve service and delivery and achieve sustainable development goals, 6, Vision 2030 and the Constitution of Kenya, many utilities are adopting data-driven innovative technologies to enhance NRW management. Okay, this is where we are. Nationally, we are at that. Benchmark is 25. I think these are stories that we have earned over time. The contributors are, as you can see, the physical losses, commercial losses, in financial loss, that is the impact and the threat to that. And also, you know, water is a right according to the Constitution, but when you lose it, people may not get it. Next slide, please. Mawasco, we are located in Nyeri County, serving Madeira East and Madeira West sub-counties with a population of around 157,000 people. And NRW in 2022 was 39%. You will, after our presentation, you will see where we are currently. Key challenges that we have faced over time: physical losses caused by leaks and burst. Of course, the already dilapidated infrastructure. Commercial losses due to meter inaccuracies. And some, at one point, there were flat rates, although we changed that, now we are 100% metered. And updated asset records, pressure fluctuations, illegal connections, delayed incident response. I'll welcome my colleague, he is Njiro, GIS expert, to continue. Thank you.
Thank you, Bwana Matthew. My name is Abimelech. I'm the GIS officer at Madeira Water. So basically, we have a GIS-based approach on NRW reduction initiatives, whereby we had a multifaceted approach where we involved updation of our assets within our network. We did a digitization of our network assets. which include, of course, having the right location of pipelines, having the right attributes, that is their material, pipe, how long they have been installed, and also we have taken an approach on DMA mapping and monitoring. Currently, we have 79 DMAs mapped, which are under a special operation called, we call it caretaker approach, whereby we involve the management CMT team. We ensure that the zone officer within that zone is responsible for reduction of NRW, the operational maintenance team. The meter reading is part and parcel of reduction as part of GIS also. So we have also done a customer linkage, whereby we ensure that whatever is billed, we are able to have a record of how many accounts have been billed. We see how our active accounts are changing over time. We can also see how many invoices we have sent. We can also locate which area has dropped in terms of active accounts, so that we can do targeted approach on why the cause reason for those changes in terms of their statuses. We have also tapped into, recently into hydraulic modeling, whereby we wanted to have an overview or a digital version of how our system works. So we've been able to, of course, pilot, of course, a DMA called Kehayo, whereby we have been able to make sure that we have the right material pipe network mapped, where the tanks, information on the tanks, the elevation along the pipe network as built, of course, and also the customers along the network, and also how much they have been able to consume and against the bulk must meter. So we've also done leak hotspots, as my colleagues from Kiambu. This is something that you have to do as a GIS officer. You have to ensure you have updated records of the leaks, how updation is done, how easily are they attended, do you have accountability on your bit, is there a record that you can generate and say, in this month we have been able to get this number of incidences, and this number of incidents have been worked on. What's the issue with these others? Is there anything that we need to ask the management for support, which we've been having? So basically, GIS is a system that allows the management to be able to visualize and also make targeted approaches that also helps in reduction of NRW. We have done spatial analytics, as they have said, is that spatial analytics allows you to incorporate the spatial component. We have attribute information on maybe we have a tank which is of this size, but let's say, for example, you are doing rotations within your zones. You need to make sure that as you grow sensitization with the community, you have to make sure that the zone officers are not kept at one place all the time. So we usually do rotational basis so that we can improve on how our culture is changing. And that needs GIS component for new people to be able to go to a new zone and assimilate themselves as quickly as possible without having to ask questions. They're able to locate all the assets. We have our assets document well articulated, and everyone, even if you are employed today, I believe within 2 days you are able to, after being taken over the training session on GIS, we are able to be in a position to be a direct user. This is a map for Kehayo DMA, which shows the Kehayo DMA reticulation network, where the tank is located, where we have our master meters and distributions of our customers. Kindly go to the next slides. In the interest of time, so basically we have done a pilot simulation of a network. As you have seen, the other is a definition of the same network over the GIS software or an environment called QGIS, but on the other end, we have replication of the same network on Ethernet, which of course involves having the right information, having the right data, doing pre-processing, ensuring that data is well validated, and also data compatibility and conversions, which of course allows you to move your GIS network into the Ethernet system. So in incident reporting, we have a mobile GIS-based reporting, which allows reporting of real-time incidents, allows the workflow of being automated assigning of those incidents on the phone, where someone receives an SMS, where someone is able to see the location using the navigation module. They are able to go to that instance, attend to it. They are able to resolve it in the system, have a photographic evidence for accountability purposes, and also have a whole holistic approach in matters incident reporting. We have also incorporated sensitization of our public to ensure fighting NRW is not a one-person job. We involve our communities. We have done sensitization through barazas, ensuring that there is a component. Apart from the staff access, we have a network, a portal for our esteemed customers where they are able to push their incidences and report them, and they'll be assigned the same way our staff will do, improving on efficiency. These are some of the system features. Of course, real-time incidents, user-friendly interface, allowing everyone to be able to report, community engagement, multi-platform accessibility. Even if an incident has just been reported, I can be in a position to assign, even here. If an incident is reported on the dashboard, I'll be able to assign using even my mobile phone. So basically, this is just a holistic approach. We have a web dashboard that allows the management to also do follow-ups, generate reports, get an overview of how we are doing in matters NRW. Some of the challenges that we have encountered is that we had to do a massive data validation, standardization, and also coming up with structures that are usually crisscross and avoid loops, and maybe portals within data collection platforms. So we have make sure that we have structured workflows. We've also had data compatibility issues that have been collected using different technology in GIS. We have been able to merge them together, have them streamlined and standardized. We've also had gap in knowledge, whereby the management has been able to do a lot of capacity building in areas that need works into improving NRW. Key outcomes, the NRW levels, we are happy to announce that we have been able to reduce NRW from 39 to 32%. Over the span of 3 years. Incident reporting by the community has increased by 60%. We have also enhanced trust and production. As you have been told recently, we have been recognized as the best water utility in governance public sector by WSREB in the recently launched Impact Report version issue number 18. Mawasco success shows that data-driven technology allows to make insightful information and make sure that you move in the right direction because you are backed by data. This can be scaled, and this is a testimonial story from Mawasco that if you put data at the center of your NRW activities and interventions, you will be able to get fruits that are visible. Thank you.
Thank you, Engineer.
Thank you very much, Mathera team. Nyeri Water, James. Yeah.
I am Simon Wahome Kiredi and James Moya, non-revenue water plumber. In our case study, it's reducing non-revenue water through step-by-step leak detection in Ulingo, DMA, Siema sub-unit. Allow me to invite my friend here to take us through from there.
Good evening, everyone. Okay. The background of this exercise was based on Nyawasco commitment to improve water distribution and reduce non-revenue water. NRW occurs when water produced and supplied into the distribution system is lost before reaching into our customers. This is due to underground leakages, bursts, illegal connections, and meter inaccuracies. So Nyawasco has prioritized NRW reduction through active step-by-step leak detection, timely repairs, pressure management, network monitoring, and accurate water accountability. NRW strategy. Why did we choose Lulingo, DMA, CMR, sub-DMA? In our area, we call them zone and subzones. We selected Lulingo, CMR subzone because its water consumption was higher than the sustaining supply in that area. So it indicated a possible water loss in our distribution network. Another issue was our customers were complaining about low pressure in their connection. So we knew if you detect this leak, they won't complain anymore. This condition made it an ideal area for step-by-step leak detection to identify underground leaks. Our objective in CMR subzone 1, reduce non-revenue. So we knew when we reduce non-revenue, automatically we will increase our revenue. Also, we knew we will stabilize the pressure to our customer connections. Procedure of step-by-step leak detection. First, you need to take daily zonal or subzonal readings. After you take them, you have to analyze those flows to know or to get a clear picture of how many units you are losing in that subzone. So you have to first excavate and look for a place where it's free from valves or beds. After that, you install the sensors. The sensors of the ultrasonic flow meter, connect and configure them, the flow meter, and put the parameters of the pipe, like size of the pipe and material of the pipe. My friend will take you through the graph.
As you can see, this graph here, this is before we attended our zone. Before we attended, we was losing 130 meter cubic per day. And after we attended our subzone, we consumed 55 meter cubic per day, bringing it to its sustaining, and we managed to save 75 meter cubic per day.
So we recommend we expand leak detection in our areas. It's important. Also strengthen staff training and continue monitoring those DMAs and sub-DMAs meters.
Good evening, everyone. I'm Aurelia Utieno, a customer care assistant at Kisumu Water and Sanitation Company. So as we wait for the presentation to okay, it's okay. It's already there. So we are doing an enhanced leak detection through quarterly scouting and a community-led initiative. This is something that we do in the company, and it has really helped us improve the non-revenue. Just go to the next slide, kindly. Just go to the next one. It's okay, thank you. So, as we all know, non-revenue is the water that we lose. And in our case, we are at 70%. We lose physical 70% of physical losses, and we are at 30% commercial losses. The commercial losses are the meter thefts and the metering inaccuracies. So the reason why we decided to do a collaborative strategy is because we understood that the amount of water that we were losing in the physical losses were more than the amount of water which we were losing in commercial losses. And the impact it brought to the performance of our utility was we had financial strain, operational inefficiencies, and service quality. Just go to the next slide. So as you can see, our distribution network coverage is at 820 kilometers, which is a vast area that the number of technical staffs that we are having cannot maintain and manage to go to all the areas. We also have a service area of 282 kilometers that makes them also like assume or have a lot of hidden leakages that we don't reach. So we are only able to reach a number of leakages, but the ones that are at the farthest end, we were not able to reach them, and it also led to delayed response. If we are not able to reach the leakages are not be able to reach, we get a lot of delayed responses, and hence the non-revenue increases. So just move to the next. So because of the challenges that we are having, we came up with the collaborative strategies in reducing non-revenue water. And the strategies that we are using is quarterly scouting that has really helped, which helps in a systematic, periodic, we do it periodically after every 3 months. And then we also have community-led initiatives. This one, we collaborate with the community. So we make the community understand that non-revenue is not only our problem, but also their problem. So we ensure that they know what we lose and what also as customers and as the community, they lose when we lose a lot of water. So we sensitize them on what they're supposed to do, and that is how we collaborate with them. We also do stuff in performance incentives, which is internal. So we make sure that when our staffs report the leakages, they are given an incentive and they are recognized. So during the quarterly leak scouting program, we do temporary recruitment. We don't do permanent recruitment because the people we use this quarter are not the same people we will use the other quarter. So we do temporary recruitment, whereby we identify individuals who are going to help us in scouting the leakages. Number 2 thing that we do training. We have to train them in what we want, the technical knowledge that we have to train them on what we expect of them and what they're supposed to do. If we just leave them to without training, they'll decide not to give us the correct thing that will not be measurable in the company. After the training, we deploy them, and we ensure 100% coverage of the 820 kilometers distribution lines that we are having. So we ensure that all the scouts are spread across the distribution lines. In the community-led initiative, as I've told you, it's a collaborative action between us and the community. After the sensitization, we get to have partners, and the partners we identify them. We identify border operators who we know they're able to get the widespread leakages, and even they also help us in illegal connections, in identifying illegal connections in the areas. We also use primary day school communities, local administration, and youth groups. During the internal staff incentives, we use this to motivate our staffs to also report leakages, and through this, we do quarterly targets We have a quarterly target that if someone gets to the target is when you are recognized, and all our incentives are performance-based. So if we have a target of maybe 100 leakages after every 3 months, so the person who gets to that 100 leakages is the person who is given the incentive and is recognized. And we also recognize according to the people who work and manage to give manage to have their turnaround times on time, because we have a stipulated turnaround time, so we also do the recognition through that. The results of our strategy has helped us to improve leak detection coverage, as I explained earlier. We are able to access the remote areas through the scouts and the community. We are also able to get the hidden leak. It's easier to discover hidden leaks now that it's not only the staffs that are involved in the leak detection program. Everyone is on the look. Everyone is responsible for checking out the leakages. The number 2 results we have, we also have faster reporting and response time. So we have real-time alerts whereby an SMS hits the customer service desk and is sent directly to the technical plumber who operates on that. Remember, we have staff incentives based on the turnaround time on the workmanship. So it helps us in the faster response. It also helps us in minimized loss duration. We currently have a low rate. Everyone wants to be fast in the repairs. The number 3 results is that currently we are having enhanced network efficiency. And we've improved our pressure management because our leaks are repaired on time and the end users get enough pressure. We also have reduced operational costs, less water wasted. When less water is wasted, we have lower cost of pumping and chemicals. And we also have data-driven maintenance. Through this, patterns in leak reports help QASCO identify sections of the network that require full replacement rather than repeated leakages and repairs. So through that, we are able to do our overhauls on time, and because it's fast-hand data. The evidence of our strategy is that we have an increased reporting volume, and we also, we are currently the responsiveness is also high. We marked an improvement in the turnaround time from 13 hours initially to current, before we were 13 hours, but currently we are at 5 hours. This is because of the incentives that we give. Everyone is now upfront and ready to work. This is the evidence. You can see in Q3 of year 2022-2023 when we started, this is when we did a pilot on the quarterly scouting. So when we did a pilot on the quarterly scouting on in 2022-2023, we realized that there was an improvement in the leak reporting. So that's, and then in Q4, and then Q1 of 2023-2024, we came and adopted, after internalizing and analyzing what happened when we were doing the piloting, we came and adapted the quarterly scouting in Q3 of 2023-2024. So since then, you can see the graph. We have improved leak reporting. In a month, we have up to the highest we've gone is around 3,200, which is a good number. And it also replicates on what we're supposed to do at what time and the repairs. If other utilities are interested, it's, the framework can be started in one area. You don't need to start in all the areas. You can just start in one area, and then you expand your incentives as the budget allows you in your utility. And then it also does not require a lot of things. It only requires human relationships and basic SMS. An example of ours, we advise the community and even the scouts that we are having to use our SMS lines, which is toll-free, so it's easier for them to report at any time. So in conclusion, Kiwasco's collaborative approach demonstrates the non-revenue reduction is as much as a social challenge than a technical one. If you use the community, it's easier for you to identify leakages at any time. At any point of the hour, we get some leakages even up to 5 a.m. in the morning, and you'll find that it's the community that are sending out the leakages. So it's not technical per se, because when we put our hopes on the technical team, you understand our employees start work from 8 to 5. So involving the community has helped us to even get leakages during odd hours, and the repairs are done promptly. The outcome, we had improved leak detections and network efficiency, as I said earlier. And the benefit is reduced physical losses and strengthened community ownership. The community own non-revenue. It's the problem of the company, but they also own it because they know the challenges that they are having. And then in future, we a sustainable model for utility management in resource-limited environments. Thank you.
Thank you very much, Aurelia from Kisumu. Let me get the next, also from Kisumu Water, Kennedy. Please take the stage. And as Kennedy comes up, the representative from Muranga Water, is he around? Okay, that was out to be the last presentation, but it gets from Kennedy.
Good afternoon. I'm Kennedy Kitinda, metering and instrumentation engineer from Kisumu Water. For this evening, I'll share with you a case study for Kiwasco on IoT-based automation for non-revenue water management. Next. So just like any other WSP, non-revenue water is a challenge. For the case study that I'm going to show us is based majorly on physical losses, where we are going to look at how we've been managing our reservoirs, managing our pressures, and also identification of leakages. Then just to get the perspective of Kiwasco, currently our non-revenue water stands at 30%. What we have as a limitation has been real-time visibility, which our in-house developed method is, we are going to see on how it has tackled it. Next slide. Now, we know that every drop counts, and water losses are a lack of infrastructure is not only the cause of our high non-revenue water, but we have the issues of visibility. We have limited network visibility, which drives reactive non-revenue water interventions and activities. So at Kiwasco, reservoir overflows contributed extensively to physical losses. As our last presenter said, our physical losses stands at around 68%, which is contributed majorly through leakages and overflows together with the pressure issues. So to tackle this issue as a company, we developed an IoT-powered automation to come and sort out this issue. So in the overview of the infrastructure of the layout, what we have developed internally is we have pressure sensors which are installed at our pumping stations and also within our trunking mains. Then coupled with that, we have ultrasonic level sensors, which are also installed within our reservoirs. So these relay data wirelessly through a LoRaWAN network, which is picked through the servers, from where now, as a utility, we are able to interact with the data through various dashboards. The diagram there is an installation of the sensor, which is installed on top of the tank, from where the aim of it being majorly to minimize water losses arising from overflows from the tanks. This is also being integrated with a WhatsApp messaging platform, which is also done through a free, an open source, really leveraging on the cost. So this equally has helped us as a company to improve our supply reliability and also to manage production planning. Next. So in it, from the graphs there is a snippet of what on a 10-minute interval we get from our reservoirs. We have a total of 12 reservoirs which serves the city. So whenever critical alerts are reached, then SMS and WhatsApp alerts are sent to operators and managers, who in turn take various corrective actions as required. Now here we have the dashboard of the automation. We have 6 key sensors of pressure and so far 8 sensors of levels, where they are preset to send an alert when critical levels are reached to the operators manning the stations. And this, as we can see from that graph, just shows the distribution of our pressure sensors and also part of our reservoirs within the system. Then how has this really helped us as a utility? In terms of prior to the deployment of this automation, we had a total of 41 reservoir overflows, which reduced to 4 upon the deployment. In terms of the volume of water lost, we had a total of close to 37,000, which reduced to 1,000. That's a reduction of 95%. Equally, the physical losses were also reduced by a ratio of 8%. So this in entirety has helped us as a utility to effectively manage water reservoirs, to effectively help us in demand forecasting of production, and also to help us in time to see which specific regions that are being underserved, so that within the network, the team is able to take the corrective measures in terms of stabilizing supply while reducing losses. So in it, apart from the levels, we have the outcome of those sensors also helps us in terms of identifying various pressure maps. So we are able to map within our network system which areas are experience high pressures, so that corrective measures are taken. So then an insight, just slowly a little, an insight for this is to note that the solution here adopted by Kiwasco relies entirely on open source, which means the initial cost of deploying this system is entirely reduced. So really what worked for us in terms of production planning, we are able to reduce our production per day from 38% from 38 million liters to 35 million liters. Then we're also able to integrate this system with our existing ERP system. So it's an integration of an open source system to an existing ERP system. So where we are now even able to integrate the same with our WhatsApp messaging system, so that being a very interactive system, our operators and line managers are able to get these insights and take various corrective actions before they occur. Then next. Then in terms of challenges experienced, of course, as much as we rely on open source platform, then there is the initial cost of acquiring the sensors. So sensors, we acquire them from elsewhere, so there's that initial cost. Then they rely on battery, but then there is the improvement of maybe making them to be solar powered. And then we equally had the initial sensor calibration also takes time, but is an issue which as a team we were able to solve out well. Then within Kiwasco, various pressure variations makes that calibrations to be done more frequently and in time because of the complexities of our network. And as a challenge, but more of opportunity, is also a point for the utility to increase the staffing, the technical support in terms of training and research on the same issues. So it is important to note that this solution has helped us to really streamline and plan effectively our production, well manage our reservoirs, and equally manage our pressures, thereby trying to minimize burst-related cases. Thank you for your time.
Thank you, Kennedy, and your team at Kisumu Water. Now, I've been alerted that we are having problem of time, pressure, and all that. But I want to allow 2 questions, and then we wrap up. But if there are any other questions, maybe we can put them in writing, and I think the team will do their best to respond. Please direct your question to any of the presenters, including our speaker today, Simon. Then we can wrap up after that. Over to you. One, the other one? The second question? Any written questions, you can direct them to Dr. here. Yes, sir.
Thank you to our presenters. These were very practical presentations because that's what you are doing. I admired the collaborative approach by, they are both Kiwascos. The first Kiwasco was the lady. It was it was Silkisum. Oh, yes. Now on the use of the community, I don't know if you can give us an indication on how do you normally take care of those borders, those school children, when they give you the information. Probably I would be interested to see, because that's a very good approach in solving our non-revenue water. Thank you.
Second question, so that they can respond. Second question. So we only have that one. Any others will be written, and we can direct them to the team. Who is going to respond? Is it Aurelia? Yeah.
It's okay, thank you. The first step is that we do sensitization, and then during the sensitization, we are able to identify the number of leakages that have been reported with the community. So after identification of the leakages, because we have a special character of how we identify them. One, we identify them through mobile numbers. So after that, we have a category of the leakages that you report that will enable us to pay you for the reportings that you've done. So we pay. Kindly allow me not to disclose that.
Yeah, there are operational transparencies and commercial secrecies.
So just to
We need to
assist,
balance.
we realized that most of the borders, they have groups. So we identify these groups, then we call them for a meeting through their leadership. Then we train them on what we expect of them. Then to the schools, again, we go to the schools, we identify schools which are majorly day schools, because they move from home to school on a daily basis. So we identify those schools, then we also train them. Then we have like a target for them, for you to be paid. So it's working for us. They meet the targets. Thank you.
Okay. Thank you very much. I want to ask, as we wrap up this session, the three utilities, Mathira, Kiambu, and Kisumu, highlighted the critical need of making use, or rather, working together with our communities. If you work with them, and this is something I believe in myself, there is no illegal connection. We have been talking about illegal connections all the time. We mention non-revenue water, but there is strictly no illegal connection. Every connection is known. And the importance of working with the communities is an illegal connection, mostly because they are known, there will not be a leak, because it will be discovered. There will not be a leak. Take analogy of ghost workers, wherever, whether it's public service or whatever. Ghost workers never miss promotion. They go for training. Because somebody will ask, I mean, why is this ghost worker not moving anywhere? Ghost workers never miss those kind of things. That means there is really no ghost, isn't it? Or if it is there, it is known. So it's important for us to leverage the potential of our communities to help us to deal with non-revenue water. The one challenge perhaps I would like Kiambu to have elaborated is how they are integrating community water schemes, because that has been a big headache. Some of those community water schemes, and I'm not saying it is in Kiambu, are actually getting water from you, but they are not paying. They are actually being supplied by you people, but it's a community scheme. That's how you know it yourself. Some claim that they have boreholes, but actually getting water from you. So that is how you work together to actually bring down this. You actually start now being serious about non-revenue water. Because for me, non-revenue water, it's being consumed, is only that revenue is not coming into your system. Somebody is consuming it. If you imagine Nairobi with half non-revenue water, half the capacity, and Nairobi has 40% of the production in the whole country, I'm sure what brought the non-revenue water average from 44 to 48 was maybe lack of action from Nairobi water, in my view. Because the moment if they cough, all of us sneeze, because it just raises the average. Now, to wrap up, I want also to not to be accused of always talking about water. We are always talking about water and always talking about governance in abstract. There are three readers I want to introduce. Why? Because two of them deal a lot with sanitation, and one of them deals with governance. So we can be governance case studies here so that we also understand governance in action, because every issue has its own governance microenvironment. So we deal with governance specifically. Don't just mention governance in abstract. You're actually dealing with the issue as governance, and there could be a problem of capacity in terms of even understanding it. But we also know that as we get successes in non-revenue water, we are getting more water. If you have more water and not much consideration for sanitation, water becomes a curse. Do you agree with that? If you have more water and you're actually not addressing sanitation, that water becomes a curse. So there are two ladies here who deal with sanitation, one in research and the other actually doing it. Betty and Leonita Sumba stand. I don't want to be accused of sidelining sanitation. It's important for these water fellows to know that sanitation is also represented here, because they are also interested in non-revenue water. Thank you very much. Leonita is in the Sanitation Research Institute, and Betty is in Fresh Life, who are dealing with container-based sanitation. I also want to introduce Irene. Irene is leading the Water Governance Hub. We have a water governance hub in this country now. You do not have to go marking benches all over in terms of. So Irene, umesimama. Nataka usimame wakuone. She's in charge of the Water Governance Hub at Strathmore University. I thought it is important for people to know because you take advantage of a high concentration of stakeholders for them to know that whatever we need, whether it is technology, whether it is governance, training or all that, it's available in this country. But I must also add, training is important, but the best training is when you are doing your job. That is when you really learn, not when you are marking benches somewhere out there. Asanteni sana.
I think we are just closing up this session, and we want to recognize the presenters of the abstract. So we'll call you to take the podium, stand, take a group photo, so that one day you might tell your grandchild that I was there. I participated in reducing the non-water revenue. Please come in front so that we can take a group photo, and therefore we can be able to end this session. It took a bit of time. Engineer Simon, my namesake, please come, come on board with the other abstract presenters, and our senior engineer, please join us so that we can be able to take a group photo. Yes, the moderator.
As WSPA, we commit to publishing a sector non-revenue water progress report within 6 months from today to track implementation of commitments made during this conference and promote accountability across the sector. Let this conference, therefore, be remembered not simply as another sector gathering, but as the moment when Kenya's water sector collectively resolved to transform technology into measurable impact.
I want to say that there are a strong relationship between Kenya and Israel, and we really want to increase this relationship also in the field of water. And I'm very happy to announce that we will establish a water forum, Kenya-Israel Water Forum, that will start next year, that will bring together experts on water from Israel and Kenya, scientists, researchers, private sector, and that we are also planning a study trip of people from Kenya to Israel.
We are in the effort of ensuring that all agencies become bulk water service providers. And our bulk tariff is as affordable as they come. You are the pioneers in the ministry, in the sector on matters water. I now want to declare this non-revenue water conference officially open.